It's been more than 100 years since the Industrial Revolution started, literally changing the world. This revolution brought the concept of assembly line and automation, and followed by information technology. It was surprisingly fast, and today we are facing a new era called Industry 4 or a smart factory. The idea behind a smart factory is to establish manufacturing system that can facilitate making smart decisions through real-time communication, forming a connection between humans and machines. This change brings a significant gain for the aerospace industry. Why? Let me give you an example. We are expecting to witness around 40,000 new aircrafts being delivered to airlines in next 20 years. Looking at the complexity of a single airplane, like Boeing 747 is made of 6 million parts that must be assembled. We need to find new smart manufacturing ways to be able to achieve this goal. But how can we get through? Advanced robotics could help us to speed up the manufacturing process. At first glance, it seems a perfect solution. But unfortunately, the robots we have today are not sophisticated enough to achieve this task. Modern robotics are prone to making mistakes and are not a perfected technology. What is the consequence? Increased manufacturing times, costs, and loss of environmental waste that more often than not cannot be recycled. Our current knowledge of engineering and manufacturing is not advanced enough to meet this issue, so we need to go a step forward and further study the mechanical performance of these defects in order to improve our quality of manufacturing. With hopes to reduce costs and the carbon footprint of aircraft manufacturing, I'm tackling this problem in my research. To that end, I'm using a robot arm similar to the ones used in aircraft manufacturing and studying exactly how severely these defects can reduce the performance of these aerospace structures. The challenge I'm facing is that these defects are difficult to predict. When looking at microscopic images, you realize that they seem to occur at random. To find a relation between the mechanical performance and distribution of these defects, firstly I'm going to perform an extensive microscopic observation joined with advanced image processing to generate sufficient data at macro level. Then I'm going to develop a model based on the concept of artificial intelligence to reconstruct aircraft structures with flaws as seen in industry. Eventually, a sufficiently intelligent and trained model can be used for simulation of the performance of these structures, so that the airline certification can adopt and industry can start using these parts instead of throwing them away. My research is going to bring security and reliability to advanced robotic manufacturing techniques, which is a key parameter for the future of developing a green aviation industry. Thank you.